Okay, in this lecture, we're going to discuss Chapter 8, which is Configuring Software-Defined Storage. And this is, I have to say, a lot of it's very, very cool. Um, so in this chapter, we're going to look at the benefits of NFS 4.1, and we'll just briefly cover that. Then we'll talk about virtual SAN requirements, virtual SAN, virtual SAN network requirements, and then we're going to turn our attention to um, virtual volumes. And I think that's basically what we're going to be looking at. So I want to move in. We're going to get past this real quick. And let's talk about the difference. And one of the biggest differences between NFS 4.1 and NFS 3. And the idea is the locks. And so let me just find that. There we go. You have in NFS 4.1 you have server-side locking, and in NFS 3 you have client-side locking. And here's the basic idea. First of all, if you're not familiar with locking is this idea. One second. Locking is this idea of someone has a file, and because of that, I don't want someone else to take that file and make changes while I'm still reading or writing to it. And so how does that occur? Well, and I'm not going to go too deep into it, but with NFS 3, it's hey, I have this, but it's kind of a system where we're expecting everyone to behave. Okay, and so you have no real guarantees on that. The big difference between that and NFS4, it's actually stateful. It's part of the protocol, the locking. Um, and it's more from the server perspective. And you get it so long because you have a lease. So uh, you'd have the file so long, and if you want longer, you'll have to renew the lease. And so they do it in such different ways that if you're going to use 4.1, you have to make sure that every component on it, or every device or host that is using it or is going to use it is set up for it, because they're not compatible. And so if you're going to use 4.1, make sure that you are consistent. And what I want to do is I want to go to the lab and we were just there in chapter 7. But so to me, we were just there. And so I'm going to go ahead and open the lab and navigate to where we created our NAS so we can kind of look at that. So excuse me just one second. Okay, and so what we're going to do is we're going to go to data stores. I'm going to right click on training, and I'm going to go to storage and new data store. I'm going to choose a type, and it's going to be in NFS, and we're going to choose 4.1. Okay, and so this is where you would choose which one you're going to use between the two, and as you remember from the last time. So I'm going to go ahead and hit next, and let's try that again. Maybe I didn't hit next. Now, another difference between NFS 4 and NFS 3 is that NFS 4.1 does have load balancing and multipathing, whereas the earlier version did not. And so that's another benefit between the two. The way we would provide the multipathing and the load balancing is we would come in here and we'd say, okay, let's say our folder, and we'll just keep with the book like I said. We're going to call this slash data store, and we'll just say 1. Now over here, apparently I didn't want to do that. Over here, we're going to provide 2 IP addresses. We'll say 7 space 192.168.5, and then I'm going to hit the plus symbol. Excuse me. I forgot to put in the comma between the two. It's yelling at me right now. Doesn't really know what I'm trying to say. So let's go ahead and add that. Hit next. Oh, wait. That's there. Good. Okay, and so that will provide us with those 2 different addresses that allow us to multipath into there. Okay, I'm going to go ahead next, and we'll go to the Kerberos. And do we want Kerberos? We're going to go ahead and say yes. Now here I'm just going to pause for a minute. We're talking about authentication. Now you remember in chapter 7 that we talked about how when you set up a NAS, you don't uh, do what we usually do in the market in the industry, which is usually you would say you would leave root squash turned on, and we said you want to turn that off. And the reason why is you would make it in NFS3, you'd make it so no one would have any permissions there. No one would have access to the root account. And so, let's see, I'm just checking one thing. And so you wanted to turn off that so people could inherit root squash permissions. In NFS4, point 1, you could still choose to leave that off. There's also another way of to assign that permission. And in fact, let me go to the book and get that. So let's go ahead and let's get the book over here. And basically the idea is that you can go to the command line and you can specify a specific host, and this needs to be consistent among all of the hosts, and it needs to be you need to be working with Active Directory, which basically you type this in and then associate it with an account. And that is a way of you could decide to use root squash or not, but it's another way of doing authentication that is not provided in NFS 3. Okay, and so I'm going to go ahead and move this to the side, and we'll just click over here just to feel like we're done. Select host. Yeah, I thought I did. Okay. I've already selected this once, so it's giving me problems. I might not be able to. I did this in chapter 7, so it's giving me problems, so I hit cancel. But that gives you an idea, and I wanted to go back to that spot. Okay, and so what we're going to do is we're going to turn our attention to virtual SANs. And virtual SANs it's a really cool idea. And so let's go ahead. So we're going to leave NAS, and we're going to talk about virtual SANs now. The idea of a virtual SAN is the idea of well, first of all, it's a vSpar cluster setting, and it's basically distributed among all of your hosts. But at the same time, it runs natively on those hosts. And the idea is you're sharing an area that all the hosts can use, that all of them provide. You need a minimum of 3 hosts, but you can have as many as 64 hosts. What's neat about this is it's a software-defined approach that turns otherwise wasted local storage volumes on these hosts into aggregate storage that can now be used to support other functionality of vCenter, which is a very, very powerful thing. Now there are hardware requirements. You've got CPU requirement, you have memory requirement, but probably the most stringent, and is the most stringent, I shouldn't say probably, but the most stringent is the hardware requirement. So I'm going to go ahead and let's look at a figure that's on the book. So here is our hardware requirement. So under storage, and this is the storage hardware requirement, but for storage, cache, then we have virtual machine data storage, and then the controller. Okay, for cache, we have 2 different things that we need. We need one serial, and this would be a serial attached SCSI, or we could do a SATA, but it needs to be for a solid state drive or a PCI flash device. That gives us the speed that we want for caching and memory buffing. Then a virtual machine storage, this is the storage itself. Right? And we could either be a hard drive, I keep trying to want to underline it, a hard drive, or it can be a solid state drive, or it could be a PCI flash device, but it needs to be storage. Okay, and usually you'll have a magnetic, a traditional hard drive or a solid state drive. It could be either, as before, a serial attached SCSI or a SATA. Okay. Lastly, you need a controller, and that needs to match what you have in here. So it needs to, when I say match, it needs to be something of these types. So it needs to be a controller for a serial attached SCSI, a SATA, or a RAID pass-through or RAID 0 mode. As far as memory requirement, it's actually you have to have 32 gigs or more memory. And then with your CPU, you don't want it to be any more than 10% of the current load. So if running this exceeds 10% of your current load on CPU, it's not a good idea and you need to upgrade that or something. Now let's look at the networking requirements. Okay, host bandwidth, a dedicated 1 gigabit for hybrid configurations, and a dedicated or shared line for 10 gigabit for all flash configurations. Connections between hosts, each must have be part of the vSAN cluster. And then you have host network. All hosts must be connected to the same layer 2 network. Multicasting must be enabled on the switches and routers that will be handling the vSAN traffic. And vSAN is currently, and as far as IP version 4, IP version 6, it must be IP version 4. IP version 6, there isn't anything built into that yet, so we can't do vSAN with IP version 6 yet. So why do this? Well, one of the reasons you do it is, if you think about why use VMware at all, why or cloud technology at all, the idea is, hey, I have all this hardware, and now I can start using it more effectively. So using uh, products such as vSpar and others, it allows you to um, provide better resource management. It does the same thing for the storage. Now I can start provisioning things. So you think about this weird idea of in storage you have this idea of I've got to start partitioning and I've got to create LUNs and all that things, and you're basically guessing how much you really think you're going to need, or you do your best not to guess, but you get as close as an accurate picture as you think you're going to get. And with this, you can actually provision as you go. So for example, as I create a new VMware, a new VM, I can say, okay, I'm going to grab this much storage for that one, and I don't have to worry about LUNs or anything else. I don't have to worry about those types of things. And if I need to add storage, I add another host, and I'm good. And so it kind of gives you um, the ability to pool those resources. Now, there's another idea that's a little bit different. It is virtual volumes. Now, this is different than a vSAN, but it's a very similar idea. And it actually goes into more of this idea of taking the guesswork out, even more so than we did before. And the book makes the case, though, that vSANs is the future, and that it's this truly revolutionary idea. And I think it probably is in a way, because instead he makes the point that in the same way that VMware and other cloud management systems help you maximize the hardware you have, this also helps you maximize the storage you have, and storage that would otherwise be wasted isn't going to be wasted. And I think that's a very good point. Now, virtual volumes have a similar idea, and it goes past what's locally given to your storage. It takes away from the gold and silver and bronze type of storage and guessing games, things like that. Like with vSANs, it does remove the extra complexity of partitioning and LUNs and things like that. Um, so it's a very similar idea to what we were talking about before with vSAN. Um, with a virtual volume, there are basically 4 things you need. So let me just navigate to that so you can actually see what I'm talking about. You need to register the software provider, and so what you do is you actually buy third-party software and you register that. Then you create a virtual data store, which we've already done. We'll do it again. Review and manage the protocol endpoints. This is a lot like SCSI. SCSI does something similar. And let's see, you modify and manipulate multi-pathing policies. And so that's what we're going to look at doing in here. So let's go ahead and let's talk about it, and then let's see how far the lab will let us do it. Because it needs third-party stuff, we may not be able to completely do it, but we'll look to see. As far as the third-party software goes, it provides the communication between the vSpar and the storage device. And so when you do that, the storage characteristics appear in your storage policy interface. Where we're going to register the storage provider is in the Management Storage Providers tab in vCenter, and we'll look at that in just a second. The credentials that we'll need doesn't like we're going to be able to do much because, and like I said, probably wouldn't anyway. You need special credentials to do that. You either get it through the vendor or you get it through someone else, some administrator, if you don't already have this. Just your storage administrator if you have one, which it depends on how big your organization is, really. Okay, so this is where we were before, and let's just act like we're going to create a new data store. New data store. In this case, we're not going to create a NAS. We're going to create a new virtual volume. We hit next after that. And actually, something I forgot, we need to register first. So let's actually click out of here. So I'm going to go ahead and hit cancel. We need to register. So let's come over here, and we're going to go to management, and we're going to go to storage providers. And so if we had one, what we'd do is we'd add it in here. We don't have a storage provider, but this is where we'd do that. And this is the password I was talking about earlier. Now that we've done that, in theory, now we can come over here and create a new storage, a new data store. And the type is going to be a virtual volume. Hit next. Unfortunately, this is probably as far as we can go because I don't have a backing storage container. So we'll hit next, even though it's going to not like us very much. And I don't have the container, so that's as far as we go. We just follow these, go through the book, and I'll show you. It's really, really simple. In fact, here, let's do this. Let's come over here and let's pretend. So we've already seen that. Come over here and you choose New Data Store. You choose the virtual volume. You can come in here, and here is your storage container. Now what you're going to do is you review your endpoints. And so let's talk about what endpoints are. What they do is they provide connection to the host and the underlying storage, much like the way iSCSI uses those endpoints. Sorry, I just turned that off. The difference is iSCSI calls them targets, but that's basically it. So and it's used to control that. But that's really as far as we wanted to go. So really what we've covered is this idea of this vSAN and virtual volume. So just barely get us a taste of it, but hopefully you'll be able to see some of the power that is associated with this. So and see some of the options that you have. So you don't have just the typical stores that we talked about in Chapter 7. You have a truly virtualized storage where, yes, you still have a storage device, but now we're kind of bringing it into the virtual world where it's managed in much the same way as some of those resources like CPUs and things like that, and memory, and so it gives it a lot more flexibility, I think, and a lot more power. So, all right, well, that's it for Chapter 8.